I'm Dr. Lutzmir, Associate Professor in the Department of Computer Science and Engineering. I'm going to take the topic boundary value testing and equivalence class testing for the subject software testing and automation. So this is the third year CSC students vertical, so it's one of the elective. So importance of boundary value testing. Why I have to study boundary value testing? Firstly, it helps in optimizing test coverage by focusing on critical areas where defects are more likely to occur. By examining boundary values, we can uncover issues related to input validation, data corruption, and handling of edge classes, leading to improved overall software quality. So, boundary value analysis is a software testing technique in which tests are designed to include representatives or boundary values in a range. The idea comes from the boundary. Given that we have a set of test vectors to test the system, a topology can be defined on that. So, basic idea for boundary value testing is to select input values, variable values at their minimum, just above the minimum, just below the minimum, a nominal value just below the maximum, just maximum, and just above the maximum. So, example, process employment application based on person's age. The problem will have boundaries. So, upper as well as the lower boundary. Age 16 is included in two different classes. So, 18 and 55. So, boundary value testing focus on the boundaries simply because that is where so many defects hide. If applicant age is greater than or equal to 0 and applicant age is less than or equal to 16, higher status is no. If it is above 16 and less than 18, higher status is part. Then if applicant age is greater than or equal to 18 and applicant age is less than or equal to 55, higher status is full. If applicant age is greater than or equal to 55 and applicant age is less than or equal to 99, higher status is no. Steps involved in this. First one, we have a step 1, identify the equivalence classes. Step 2, identify the boundaries of equivalent classes, or maybe the upper as well as the lower boundary. So create the test cases for each boundary value by choosing one point on the boundary, one point just below the boundary, and one point just above the boundary. Below and above are relative terms and depend upon the data value units. So equivalence class testing. Its equivalent class is formed of the inputs for which the behavior of the system is specified or expected to be similar. Each group of inputs for which the behavior is expected to be different from others is considered as a separate equivalence class. For example, the specification of a module that determines the absolute value for integers specify one behavior for positive integers and another for negative integers. In this case, we will form two equivalence classes, one consisting of positive integers, the other consisting of negative integers. We should define the equivalent class for valid inputs also. Equivalent classes are usually formed by considering each condition specified on an input. If an input condition specifies the range of values, so the count lies between 0 and maximum, then the valid equivalence class with the range. Two invalid equivalent classes, one with the value less than the lower bound range, count is less than 0, and the other is count is greater than max. So if the input specifies a set of values and the requirements specify different behavior for different elements in the set, then a valid equivalence class is formed for each of the elements in the set and an invalid class for an entity not belonging to the set. One approach is to determine the equivalent classes. If we know the entire range of input, that will not be same in the manner. We can split into two or more equivalent classes, each one containing the values for the behavior will be similar. So, for example, for a character input, if you have two reasons to believe that the program will perform different actions, if the character is an alphabet, a number, or a special character, then we should split the input into three valid equivalent classes. Another approach is forming equivalent classes. Consider any special value for which the behavior could be different as equivalent classes. For example, the value 0 could be the special value for an integer. For each valid equivalent class, one or more invalid equivalent classes should be identified. Equivalent classes in the output. For an output equivalent class, the goal is to have inputs such that the output for that test case lies in the Output equivalent class. Example, a program for determining rate of interest for some investment. There are three clear output equivalent classes: positive rate of return, negative rate of return, and zero rate of return. The three kinds of inputs for each of the output generated. It is difficult to determine the test cases for output classes, but output classes reveal those errors that are not revealed by input classes. So after selecting the equivalent classes, next we have to select the test cases. So strategy, you will be having two strategies. First, one strategy is selecting the test case covering many valid equivalent classes. So one separate class for each invalid equivalent class. Another is I have to have a test case that at most one valid equivalent class for each input and have one separate test case for each valid invalid equivalent class. The total number of test cases for valid E is classes are largest number of E classes for any input plus total number of invalid E classes. For example, consider a program that takes two inputs, a string s of length up to n and an integer n. The program is to determine the top n highest occurring the number is n is. Selecting the test cases, first strategy, one test case will be s as the string of length less than n, considering the lowest case uppercase number and special character. N has the number 5. The one test case cover all the valid equivalent classes, equivalent class 1 through 6. So then we will have at least one test case each of covering one equivalent class 1 for 3. So we will be having 4 test cases. Second approach, one test case we can cover one equivalent class for one input only. The string of numbers will be 5t. It covers equivalent class 1 to 6. Then we have the need to test the test cases from 2 to 5. Then separate test cases for 1 to 3.